Okay, so we're going to move on to question 2 now. The question with number 2 is develop 95% confidence intervals for the mean age and household income of subscribers. So for the mean age and household income, let's take a look at this. Here we have age. Make sure you clear out your filter. Here we have age, and I also want to clean this up. So let's go to my highlighter. Okay, so we're looking at age in this, and we're looking at household income. We're looking at both of these. All right, and we want the confidence interval. And what is a confidence interval? So let's get into that. We're going to start with household income. And we already talked about all of this, so I'm going to hide these columns so we can get over to the next set. If you want to hide information, you can right click and tell it to hide. That's also where unhide is. So you'll notice where now we go A, B, T, and the T gives us, where we're going to start talking about confidence intervals. But if I wanted to unhide this, just right click, unhide, and everything else comes back. So for me, this is super useful, especially with large data sets that have a lot of columns where I might want to compare, for example, column A to column Z. I want those side by side. Anyway, just a sidebar. So the confidence level means the percentage of times you can expect to get the same estimate or the same result if we rerun the test. So that's down here for confidence level. I want to put that back to number. The confidence interval is the upper and lower bounds. Now we have to calculate this. So going back to confidence level, we have 410 people in the data set. We've already talked about the skewness and kurtosis, if that could be relied upon. It's telling us it's not a normal distribution. So we couldn't necessarily generalize this to a larger population. Now, if we were just looking at these 410 people, maybe to do an investment portfolio for these 410 people, then you could rely on this data set. But if we're going to try and generalize it, let's say to the whole population of the United States, it's not enough people. If we wanted to generalize it even to the whole population of a city, it's probably not enough people because we're seeing these skewness and kurtosis numbers are just not good enough. We're seeing the standard error numbers pretty big. And so what we're going to do here is with the confidence level, it says, if we redo this same test over and over and over and over again, will we get the same results? And we want 95% accuracy. So we're not considering generalizing it to a larger population. We're not considering, running it today versus running it a year from now with new information. It's basically the same information rerunning it. Now the confidence level, we're looking at upper and lower bounds. So here we have lower, here we have upper, and we have to calculate this. We have to use the mean and the confidence level to do that. So you'll see I already have the formula in here, but basically for the lower number, we're going to do equals. We'll take the mean, or that's the average, and subtract the confidence level. And there you get your lower number. Just do the same thing with the upper, but add it instead of subtracting it. And that is your upper. So essentially it's telling us 95% of the time you can expect household income to fall between these two limits. That should actually be lower and upper limits. I would word it. Lower and upper limits. So 95% of the time when we run this data set, we should expect the information to fall between $71,079.26 and $77,839.77. That's what our confidence level and confidence interval means to us. Now we want to do the same thing for age. So if we go over here to our data set and we look at age, we're going to go to, and you should already have this from the previous question, but you can go to data analysis, descriptive statistics. We want this to be age. And we want this 95%. Now, some people might say you want it 85%, 90%. It's most commonly referred to at 95%, but you do have the option to change it there. Okay. So again, we're looking at mean and we're looking at confidence interval. All right. And we want to do the upper and the lower. Oops. So we're going to put in our formula equals the mean minus the confidence level. Oops. Equals mean minus confidence level. And we want to do the upper equals mean plus the confidence level. Okay, so we can say with 95% certainty, our data will fall between ages 29.7 and 30.5. I hope that helps. All right, let's move on to the next question.